what is the difference between total number of squares in figure 1 and figure 2 given below? There are two figures given to us. Figure 1 is a matrix, 3 by 3 matrix. Figure 4 is a 3 by 4 matrix, right? 3 rows and 4 columns. He's asked us to find out the difference between total number of squares in figure 1 and figure 2. So find out the number of squares in figure 1, then the number of squares in figure 2, and take the difference. Of course, options have not been given. I'm sure different answers will be obtained by different students in this case, but let's directly deal with it. So what do? One is like we have been doing, just number each part here, A, B, C, D, E, F, G, H, I, and then count, right? He's asked us to find out the number of squares, right? So squares, you know, for a figure to form a square, I mean, when there is a symmetric figure like this, again, there can be unit squares, which means made up of one square. There can be squares made up of 4 squares. There can be squares made up of 9 squares. See, 3 squares, 2 squares, 5 squares, 6 squares will not make a square, right? Square is like, again, it should be like perfect squares, right? Number of units of squares that you use should be either 1 or 4 or 9 or 16 and so on. Yeah. So unit squares will be how many? A, B, C, D, E, F, G, H, and then I. So total 9 already. Then you don't even have to look at 2 squares. 2 squares will not make a square. 3 squares will not make a square. 4 squares can make a square. So what are the 4 squares? A, B, D, E is one square. B, C, E, F is the other square. D, E, G, H is another square. And E, F, H, I is another square. Right? So if you have to kind of name it, A, B, D, E is one. B, C, E, F is the other. Then D, E, G, H is the third one. E, F, H, I is the fourth one. Yeah, there are only 4 unit squares. And then, of course, after 4, we directly jump to 9. Using 9 unit squares, the only square that can be made is AI, right? A to I, so to say. Yeah. So how many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So total count is 14. A similar operation can be done here as well, right? You can say A, B, C, D, E, F, G, H, I, J, K, L. And then you can count unit squares, squares made up of 4 units, squares made up of 9 units, squares made up of 16 units. Of course, 16 units are not there, but up to 9 you can count and get the answer. But let me give you, I mean, while you can do that and get the number of squares, let me give you a shortcut, right? The formula, which you are all interested in, right? So what is the shortcut? Remember, this shortcut is only for counting squares, only when matrices are given to you. It doesn't work elsewhere, right? That's why I always say shortcut comes with a star. This means conditions apply. So you have to remember all these conditions. For different figures, we have discussed different shortcuts. You have to be very, very clear about the conditions there, right? Limitations are there. With every shortcut, there is a limitation. It is applicable only in this type of question. So this shortcut is applicable only when such a figure is given to you. What's the shortcut? The number of squares can be counted as follows. Number of squares will be equal to, see, let's say the number of columns are C. Number of columns is equal to C and number of rows is equal to R. Let's assume number of columns and number of rows are C and R respectively. Like for example, here we have got 3 rows and 3 columns. Here we have got 3 rows and 4 columns. So what's the formula? What's the formula? Number of squares will be equal to C into R plus C minus 1 into R minus 1 plus C minus 2 into R minus 2 plus C minus 3 into R minus 3 plus C minus 4 into R minus 4 and so on till you get 0. I mean, at one point it will become 0, right? Either the number of columns will become 0 or number of rows will become 0 when you subtract 4 or 5 or 6, right? Depending on number of rows and number of columns. So you have to go on, do this operation till you get the final answer. It converges to 0 basically. Somewhere it converges to 0. So number of squares, that's how you count it. Like for example, if you have to apply this formula for the first figure. So in the first figure, C is equal to 3, R is also equal to 3. So what will be the number of squares? Number of squares will be equal to C into R, 3 into 3 plus C minus 1 into R minus 1. So 3 minus 1, 2 into R minus 1, 2 minus 1, 3 minus 1, 2 plus C minus 2 into R minus 2, which is like 3 minus 2, 1, other 3 minus 2, 1 plus C minus 3 into R minus 3. So 0 into 0. And after that anyway it will become, I mean, you cannot consider, sorry, Yeah, after that anyway it will become 0. You cannot consider negative value. I mean, you cannot subtract anything from this. So what will be the total? It will be equal to 9 plus 4 plus 1. 9 plus 4, 13 plus 1, 14. See, that's what we had got, right? We had got 14 here. So balanced, I mean, correct. Count the number of figures in, number of squares in figure 2. In figure 2, we know that number of columns is equal to 1, 2, 3, 4. C is equal to 4. Number of rows is equal to 1, 2, 3. So what will be the answer in this case? So number of squares here. What will it be? 4 into 3 plus C minus 1, R minus 1. So it becomes 3 into 2 plus C minus 2, R minus 2. So 2 into 1 plus C minus 3, R minus 3. So C minus 3 is 1, but R minus 3 is 0. So the moment you get 0, you can stop. Up to 0. Right? So the moment you get 0, you stop. Here also, when the moment you get 0, you stop. Right? So we got 14. What's the answer here? So 4 into 3, 12. 3 into 2, 6. 2 into 1, 2. 1 into 0, 0. So 12 plus 6, 18. 18 plus 2, 20. So the total is equal to 20. So the number of figures, squares here is 20. Number of squares here is 14. He's asking us to find out the difference. What is the difference? Difference will be 20 minus 14, which is equal to 6. So the final answer to this question will be 6. But then it all depends on counting the number of squares. So similarly, let's say if he has asked you to count the number of squares in a chessboard. What will be the number of squares in a chessboard? Chessboard has got 8 rows and 8 columns. So basically it will be like 8 into 8 plus 7 into 7 plus 6 into 6 plus 5 into 5 plus 4 into 4 plus 3 into 3 plus 2 into 2 plus 1 into 1. So it's like 8 square plus 7 square plus 6 square plus 5 square plus 4 square plus 3 square plus 2 square plus 1 square. Right? Suppose there is a 8 by 7 matrix, 8 by 7 table. Right? 8 by 7. Remember that table should have all squares only. You know, it should be symmetric. The cut should be equal. You are getting it? Otherwise this technique will not work. That's why I'm saying you have to be very, very careful. This conditions apply is a very important point here. Right? Like for example, if I give you a figure like this, for the sake of argument, let's say this is the figure. This is a figure, let's say. Can you apply the formula here? No. Because each unit here is not a square. While this is a square, this looks like a square, these 6 are squares, this is like a rectangle, right? And these are clearly rectangles. Here you cannot apply the formula. C into R, C minus 1 into R minus 1, C minus 2 into R minus 2. You will get a wrong answer. The figure has to be made up of only squares, like a chessboard, 8 by 8 squares, right? Anyway, the shortcut is C into R plus C minus 1 into R minus 1 plus C minus 2 into R minus 2 and so on till you get 0. Add all these values to get the answer. So here, first figure has got 14 squares, second figure has got 20 squares. The difference is 6.